All right, welcome back to our channel. We're doing 8.2, which is called Yard Work in Segments. And we're solidifying understanding, and we're going to be able to locate the midpoint of a segment and a point that divides a segment in a given ratio. And how can I locate the midpoint of a segment given just the coordinates of its endpoints? And how do I divide a line segment drawn on a grid into proportional parts? So you may have, it may, like this lesson will make a lot of sense to you because it's just finding the midpoint. A midpoint just means that you're finding the middle point of a segment. So in my brain, it divides that segment into two congruent parts. Okay. Um, so Malik's family purchased a new house with an unfinished yard. They drew the following map of the backyard. Okay. And then it says Malik and his family are using the map to get up gardens and patios for the yard. They plan to lay out the yard with stakes and strings shown as points and dotted lines in the map so that they know where to plant grass, flowers, or vegetables. They want to begin with a vegetable garden that will be parallel to the fence shown at the top of the map. Okay. Okay. They set the first stake at -9.6 and the stake at the end of the garden at 3.10. They want to mark out the middle of the garden with another stake. Where should the stake that is at the midpoint of the segment between the two stakes be located? Using a diagram, describe your strategy to find the point. So this is where I'm going to pause you. You're going to find where the midpoint is for this segment, and it just makes sense. So this is not anything that you've ever learned, but just try to have yourself understand it. Okay. And so some of you may have, so go ahead and go do that and then come back to me when you are done. All right. Now that you're back, some of you may have drawn like a right triangle, kind of like a slope triangle, right? So you go this way, this much, and this way, this much. And maybe you counted and you said this is 12 this way and 4 this way. So the midpoint has to be in the middle and the middle. So halfway between 12 is going to be 6. So I'm going to count 6. 1, 2, 3, 4, 5, 6. And 2 would be somewhere here. Kind of like I'm looking at the halfway points here. Okay. So this is where I'm proposing that midpoint be. So Malik figured out that the midpoint by saying it makes sense to me that the midpoint is going to be halfway over and halfway up. So I drew a right triangle and cut the horizontal side in half and the vertical side in half like this, just like we did. Right? Malik continued, that put me right at -3. The only thing that seems funny about that to me is that I know the base of the big triangle is 12 and the height was 4. So I thought the midpoint would be 6.2. And if you actually graph 6.2, 6.2 is all the way over here. So do you think that could be the midpoint of that segment? And of course, everyone's like, no, but 6.2 is not a coordinate point. That's how far it was horizontally and vertically from each of the endpoints. So make sure that you're able to explain that. Malik's sister Sapana looked at his drawing and said, hey, I drew the same picture, but I noticed two smaller triangles that were formed that were congruent. Since I didn't know for sure what the midpoint was called, I called it XY. Then I used the point to write an expression for the length of the sides of the small triangles. For instance, I figured out that the base of the lower triangle was x minus -9. So she's saying this point here is x minus -9. Because minus -9. Okay, so that would be the coordinate. So label all of the other legs of the two smaller triangles using Sapana's strategy. So they just want you to label how long each side is. So go ahead and do that. Give you a couple seconds. Come back to me when you're done. Okay, so this right here is what Sapana is labeling x minus -9. That's how long that segment is. So if you remember from the distance formula, the way you find the distance between 2 points is you just subtract, right? You subtracted the x coordinates. That's part of your distance formula. So same thing goes with your y's. So then this distance here would be y minus 6. Everybody see that? That's y minus 6. So go ahead and label the other two sides of the smaller triangle based on that information, right? And so you get 3 minus x, and this would be 10 minus y, right? So Sabina continued, once I labeled the triangles, I wrote equations by making bases equal and heights equal. So then she said, since I knew that these were two congruent triangles, I could say that this side is equal to this side. Okay, so let's try x minus -9 equals 3 minus x. And then the other equation she wrote was y minus 6 equals 10 minus y. So let's just go ahead and solve those just to make sure. We get x plus 9 equals to 3 minus x. So then I would add x to both sides. At the same time, I subtract 9, and I get x is equal to -6. And here we get 2x equals to -6. Therefore, x equals to -3. And 2y equals to 16. So therefore, y equals to 8. And if you look at that point, that is the point -3, 8, right? So does her strategy work? And if so, why or why not? And then now choose a strategy, whichever one you want to use. If you want to use Malik's strategy, or if you want to use Sapana's strategy, go ahead and do number 5. Okay. Now go ahead and do that and then come back to me. All right, now that you're back, I'm going to show you. So Malik's strategy had you graphing them. So -3, 4 is here. And 2, 9 is here. Okay. And then what they had you do, or then what he did, is he wanted to find the midpoint by kind of looking at the triangle here. So 2 minus -3, this was 5. And 9 minus 4, this is 5. Right? So then if you split this in half, this would be 2.5. Right? And then 2.5 would be like this. It would look something like this. Right? So then, according to that, that would be -half, which I like fractions better. Hold on, let me do this as fractions. So -half, and let's see, 2.5 from 9 would be, 9 would be 18 halves. 18 halves minus 5 halves is 13 halves. Okay, so 13 halves. Okay, so for those of you who don't like fractions, fractions, I'm just going to say, are somewhat better to deal with in the land of algebra. So just keep that in mind. If you use Sapana's strategy, you would have found her finding how long this side was here. So she went x comma y. So this would have been x minus -3. And then this would have been y minus 4. And then this one would have been 2 minus x. And then this last side would have been 9 minus y. And then so if you would have solved those equations, x minus -3 equals to 2 minus x. So that would have been 2x equals -1, so x equals -half. That's correct. And then same thing goes here. We would have gotten y minus 4 equals 9 minus y. So 2y equals to 13, y equals to 13 halves. So yeah, we got the same exact answers, right? And it should be, right? So now they want you to come up with a formula for this. So using either strategy, right? Go ahead and come up with your strategy for finding the formula. Now, this formula is going to work every single time. So if you're more like Malik's strategy, you're figuring out how long is each side and then doing it like that. Okay. So Malik's strategy would have been like this. It would have been, let's see, x2 minus x1. And then you would have divided it by 2, right? Because that's what we did here. And then you add it to your x1. So it would be x1 plus x2 minus x1 over 2. Now, if you add these together, because you want them to be, this is quite a messy formula. So then you would have the common denominator. So I'd multiply it by 2 over 2. So then it looks like this. It's 2x1 plus x2 minus x1. Well, you can simplify that to just x1. 2x1s minus x1 is just x1. So here it's going to be x1 plus x2 divided by 2. So that's my x coordinate. So my x coordinate is going to be x1 plus x2 divided by 2. Now you can do the similar thing to y, right? If you did this, you would subtract your y's. So it would have been y2 minus y1. And then you would have divided it by 2 because, right, you wanted that middle. And then you were going to add it to y1. So this would have been y1 plus y2 minus y1 over 2. And then do the same exact thing. So we would have gotten 2y1s plus y2 minus y1 all over 2. But then 2y1s minus y1 is just 1y1. So y1 plus y2 over 2. So don't worry if you did not figure this out all completely on your own. The whole goal is if you understand where this formula came from. So this is your midpoint formula. So you're just going to basically add your x's, divide by 2, add your y's, and divide by 2, and there goes your midpoint formula. Okay. So that's your midpoint formula. Now, if we get into other questions like down here, so the area of the garden in the is to be marked in a flower garden. Malik's parents have the idea that part of the garden should be a big rose bush and the rest of the garden will have smaller flowers like petunias. They want the section with the other flowers to be twice as long as the section with the rose bush. The stake on the points will be 1, 5, and 4, 11. Malik's dad said, we'll need a stake that marks the end of the rose garden. Help Malik and Sapana figure out where the stake will be located if the rose bush will be closer to the stake at 1-5. So they basically want to cut this section up into parts. Now before we were cutting it in half. I wanted the midpoint, the point in the middle. But here they don't want that. They don't want the halfway point. They want so that one part is twice as long as the other part. So that it's going to start off exactly the same, right? Where you kind of like Malik would do, you would draw these in like this, right? And you would count, okay, this is 6 and this is 3. And then you kind of have to be wise about if one part is going to be twice as long as the other, you're basically cutting it into 3 parts. Okay, you're basically cutting it into 3 parts. Why 3 parts, Ms. Johnson? Well, that's one part, has to be twice as long, that's 2 parts, as the other. So that means a total of 3 parts. So you want me to cut this segment into 3 parts, Ms. Johnson? Yes. By cutting it into 3 parts, really you're just cutting the horizontal distance to 3 parts, right? And you can kind of see that here. And the vertical distance into 3 parts, like we see here. So if you want to do like Malik, he's going to go like this kind of. And then this is going to be where that stake is going to be. Okay. Which, let's see. It's 1 to the right. So now it's 2 and 2 up from 5. So that's 2 comma 7. Okay. And so the way that we did it is we drew our triangle and we divided into the total number of parts, which was 3. And then we counted and we saw those 3 parts. And really, you're just breaking it up into its horizontal and vertical distance. So I'm going to have you do this one here, number 8. It says there's only one more set of stakes to put in. This time the end stakes are at -8.5 and at 2.10, 2 -10. Another stake needs to be partitioned out, so it's 2 parts are in the ratio of 2 to 3. So again, you want a total number of parts, not just the 2 part or the 3 part. Here we split it up into a total of 3 parts. When we were splitting the triangle in half, or the segment in half, we were going for a total of 2 parts. So you want to know the total of 2 parts. So how many parts should this be divided up into? And then when you draw your triangle, you're going to segment it out so that there's an even number of space between. Okay. So with that being said, go ahead and try this one and we'll talk about it the next time we see you. When we work on this part here, you're just trying to divide it into parts. Now that you know the midpoint formula, you can use it and you don't need to necessarily use Sapana's or Malik's way. Okay. So thank you so much for listening. I hope you have a great day. Bye.